So hey everyone, and first of all, thank you very much for attending the very first Workspace live code along. A colossal thank you as well to our speaker of today, Ramnath Vaidyanathan, who together with DataCamp and you made this event possible. First of all, a link was shared in the chat related to the template that you will be using throughout the session. In case you haven't opened it yet. In case you have, I would like to point out that in order to go back to the template that you have worked on, you should open it from the dashboard of Workspace itself. Because if you re-click on the link, then a new template will be created from scratch. So be careful, please. A little bit about DataCamp itself. Ramnath, thank you. Our mission statement is to democratize data science education and make data science fluency accessible to millions of people and businesses around the world. Our speaker of today, Ramnath Vaidyanathan, is the VP of Product Research at DataCamp, where he drives product innovation and data-driven development. He has more than 10 years of experience doing statistical modeling, machine learning, optimization, retail analytics, and interactive visualizations. So you name it. The first live code along is divided into several parts. First, the speaker will solve the first question of the template and also showcase already some features about Workspace. After this part is covered, we will ask you to vote on the second question we should solve, and during this time, we will have a short Q&A. So we recommend you leave some questions on the side. For example, note on the line of the notebook which line you had a question, so we can further address it in the Q&A. Next up, the speaker will go over the chosen second question, and in the end, a small Q&A session will be held for this as well. Both Q&A sessions will be around maximum 8 minutes long. Finally, the speaker will give some remarks about the template, and I will say some closing words. So we hope to be done within an hour from now on. We hope you enjoyed today's session very much, and we want to remind everyone that this session is recorded, and the link will be posted later on Slack and social media platforms. Thank you very much for your attention, and now into the event itself, I pass the stage/frame to our speaker, Ramnath. Thank you very much.
Thank you, Rio, and welcome to everyone joining this first live code along for DataCamp Workspace. So as Rio explained, the link to open your workspace in order to follow along and do some live coding along with me, click on that link and it should take care of things. If you have any issues, please feel free to let us know in the chat. Someone will try to help you. So before we get started, what is DataCamp Workspace? So DataCamp Workspace is basically one of the newest products of DataCamp. Essentially, it is like having an entire data science platform on the cloud. You can basically use your favorite editors, Jupyter Lab, which is what we're going to be showcasing today, our studio, and you get to code in the cloud. So everything in the cloud. And more importantly, you will also be able to publish your work, share your analysis, and create an entire data science portfolio. And we have a lot of exciting things lined up on what we want to kind of make DataCamp Workspace into. But today's code along will focus on using DataCamp Workspace to analyze a really interesting data set on baby names. So without much ado, we're going to get started. Again, as a reminder, if you want to code along with me, please feel free to click on the link that was shared in the chat. That should open up a workspace. And if you basically do that, you will be able to get to a screen that looks like this. So let us get started. Just a quick tour of what Jupyter Lab, if you've not used Jupyter Lab before, Jupyter Lab is one of the premier data science IDEs. You can do a lot of interesting stuff. You can write code, you can run code, and it really gets you going in a big way. And if you opened this whole workspace, you will see a screen that looks like this. On the left-hand side, you will be able to see all the files. And the file that we'll be using for this code along is called notebook.ipynd, and it should be the default that should open up for you. And on the right-hand side, you see the notebook. And essentially, each of these blocks. These are called cells in JupyterLab, and I will show you as we go along how to use these cells. So let's get started with the analysis. So before we go to the questions, we're going to do a couple of things to set the tone going. So the very first cell here, if you navigate to the cell, it's basically installing a couple of packages that we will need. Most of the packages already installed, and if you want to run this cell, so there are two ways to run a cell in JupyterLab. One is you can use this icon, click on it, and that's basically going to run this cell. And for the case of this cell, I have chosen to hide the output because it's not interesting. It's basically a lot of installation text. And you will see that when I clicked on run, you will see that this cell, it turns, there is a star, which means that the cell is running. And then once the cell completes, you will see that it returns a number, which basically means everything is good. So we're just going to run the cell. And the other way of running a cell, which is what I would be doing, so you won't see me go here and click on this, but you can choose to do that. That's completely that completely works. Let's kind of do the second method here. So the second method here, so here we're going to import all the libraries, and I'm doing this upfront so that you don't have to be bothered installing and loading libraries as we do the analysis. So the second way of doing it is using the keyboard. So you could use Control Enter or Shift Enter. Both of them should work. I did Control Enter here, and basically at this point, all the required libraries for the analysis have been loaded. And you can see if you've been doing Python for data science in Python, you see some usual suspects: Pandas, the Swiss Army knife of data science, and then you have NumPy. And then on the plotting side, we have Matplotlib and Plotly Express, which you'll be using to a good extent. So at this point, we're all set up to do the analysis. So let's dive straight into the data set. This is one of my favorite data sets. It's a really simple data set of baby names. It is collected by the Social Security in the US. It's 100 years of data. It's a really simple data set, but you can do so many different kinds of analysis data set that the possibilities are endless. Like we could fill 20 webinars just with analysis of baby names. So let's get started. As is the case with any data analysis, the first step is to read in your data. You will notice that we've already downloaded the names file. You can see it on the left-hand side. It's called names.csv.gz. That's a CSV file, just gzip so that it occupies less space. We will start by using Pandas to read in this data set. So let's do that now. So I'm going to basically create a variable called baby names to store the data, and I'm going to use PD, which is what we've imported Pandas as, PD read underscore CSV, and then I'm going to basically put in the name of the data set. So this should read in the data set. And just to know that I've loaded the data set correctly, I'm basically going to use babyname.head. And this is basically telling JupyterLab, hey, I want you to display the first couple of rows of the baby names data set. So let's run this code and let us see what it gives us. So if you ran this code, you will see that this data set consists of 4 columns. As I said, it's a pretty simple data set. The first column gives you the name. And so the Social Security reports any name that has had more than 5 births in a given year. So it's kind of not all the names, but like a good share of all the names. The second column is basically sex, and this is essentially male or female in this data set. And then the third and fourth columns talk about the births, the number of people with a particular name born in that year, and then the fourth column is year. So that's basically the setup. So let's get started on the questions. And the way we're going to basically do this, as I said, the possibilities are endless, but we only have so much time. So the way we're going to do this webinar, this code along, is we're going to start with one question, which is on what are the most popular names. It's usually the question that most people immediately get started with. So we're going to do that. But to make things more interesting, there are 5 other questions that I've listed here, which you will see again. And you are going to vote later in this code along. You're going to vote for the question that you would like to see, and we will pick the question with the most upvotes and essentially do that in the second part of this code along. So brace yourself up for lots of fun. And as I said, if you have questions, please feel free to use the chat so that we know what any difficulties you're facing or any questions you have. We'll try to address a good part of it. So let's get to the first question. So one of the first questions is we want to understand naming trends. So let's just figure out what are the top 5 most popular names of this decade, right? And just to be clear, we are looking at all babies born on or after 2000. I mean, on or after 2010, basically, right? So the way I like to do this, again, you might, for those of you who've been using Python for quite some time, yeah, this might be a little different. I'm going to be using method chaining a lot, and part of the background is I come from the world of R, and yeah, I like this style of coding, and so we're going to use method chaining, and it's also easier in a code along, so you can see everything that is happening. So let's just get started with the data set. I just do this to sort of make sure that everything is running. So the first thing we want to do is we only want to look at babies born 2011 and later. So to do that, we're going to filter this data set for only those rows. There are many different ways to slice and dice data in Pandas. For this particular filtering, I'm going to use the query method. The nice thing with the query method is it's very concise. So inside the query method, you can basically pass in like a SQL kind of query. And here I'm going to say year is greater than 2010. So this will basically give you all the babies who were born after 2010. And let's just run this code cell to make sure that everything is good. Okay. So we do see that, yeah, I mean, you only see the first 5 rows. So, and it's not ordered. So we basically, it looks fine. We will know as we do the remaining pieces. So the next thing we want to do is we want to get the most popular male and female names of the decade. So what we want to do is we want to essentially ignore the year column. We want to aggregate the data across the sex and name columns. So let's do that. The way to do that in Pandas is we use the group by method. And inside the group by method, we're going to pass the 2 columns that we're going to aggregate by. So in this case, it is sex and name. And the column that we want to really focus on is basically the births column. So what I'm going to do is I'm actually going to select the births column so that year is not really in the picture. And then I'm going to use the method sum. And basically what the sum method does is it essentially sums up whatever columns you have that are not the group by columns. So let's just run this again. And so there you go. So you see now you have sex, you have name, and you have the births. So now we have the births column, but basically we still have more work to do because you want to figure out what are the top 5 names, right? So to do this, there are many different ways to do this, and let me show you one way of doing it. So what we need is we want to sort the values of births in descending order, and then we want to pick the top 5 for each sex, right? So let's first do the sorting here. So we're going to use sort values. We're going to use the method called sort values, and the first parameter that we're going to pass is by, and let's basically say we want to sort by sex and also by births, okay, so that the sorting is maintained within each group. And we want to sort in descending order, so we're going to say ascending equals false. The default is true. So we're going to set ascending equals false. So this will basically sort, but we're still not done. What we still need to do is we need to pick the top 5. So we are going to again group by sex, and we are going to then take the top 5. So basically, we're going to say 5 here, so it's very clear that it's only 5. So let's run this piece of code now. There you go. So you see it's listed the top 5 names, male names, the top 5 female names. One thing you notice is that sex and name are still sort of not showing up as columns. These are indices in Pandas, which is kind of a very nice feature, allows you to do a lot of performant analysis. But for plotting, it's good to have like a flat table. So to do that, what we're going to do is we're going to use the Pandas method reset index. And if we do reset index, basically we're going to get a data frame that's basically just flat. And the last step, we will assign this to a variable, popular names, and let us print popular names again so that we're all good. So just to summarize what we did, we started with the baby names data set. We filtered it to only include those rows that are after 2010. We grouped by sex and name. And then we took the births column, which is the column we're interested in. We aggregated the births column so that there is only one row per sex and name. Then we sorted it in descending order. We grouped by sex and basically picked the top 5. Okay. There is another way to do it using a method called nlargest. So for those of you who are familiar with that method, yeah, you can do that as well. But this is the one that I chose here. So let's now get to the next part, which is like plotting this. And before we move any further, I also want to remind you that there is also a notebook called Notebook Solutions. So if you get stuck at any point and you really want to see like the code, just feel free to click on that. But I would recommend not using it unless you get stuck, because you'll get more from the code along by sort of following what I'm doing and trying to reproduce the same. So cool. So we have the popular names data now. So now we need to plot it. And what we're going to do is we're going to plot a horizontal bar plot of the births by name, faceted by the variable sex. So we're going to use an interactive plotting library, Plotly, which is one of my favorite libraries. It really allows you to plot interactive plots with minimal amounts of code. And in particular, we're going to use Plotly Express, which is essentially like a much more simplified way of creating plots. So we're going to start with PX, which is the Plotly Express module we've imported. And we want a bar plot. So we're going to say px.bar. The first variable, the first parameter we're going to pass along is the data set. So in this case, it is popular names. Let me get my indenting right. Then the next variable we're going to pass is the x variable. In this case, I want a horizontal bar plot. So on my x-axis, I actually want the births. So I'm going to say births. And on the y-axis, I want the name. And I want to facet it by, so I want to show different panels for male and female. So the way I'm going to do it is I'm going to use facet row, and I'm going to basically say sex. So let's see if this plots something. So let's run the code, and there you go. So you get a plot. It's okay. It's not great. So one of the first things I notice here is that you see that the x-axis, the y-axis basically repeats like all the names, and the ordering is kind of not clean. The reason that happens is that you have different, these two facets have different values for the names. So we're going to fix that by using another Plotly method. So I'm going to save this figure as fig, and then I'm going to say fig update layout. And what we're going to do here is there is y-axis 2, which is the two y-axes because there are two panels. And what we're going to say is that please don't match the y-axis, right? Because it's trying to match the y-axis. That's why you get this sort of really clunky looking plot. So let's run this. Much better, right? So now you see that it's able to display the 5 names. It's not trying to match the y-axis, so it's okay if we have different ones. The one thing that still I don't like, the bunch of things I don't like, and so let's kind of like clean up the plot a little bit so that we have something that is neat. So the first thing is you see that it's kind of, I mean, our data frame is actually descending order, but the plot is kind of ascending order, and this is basically how Plotly does it. So we want to fix that. Other things we want to fix, like really, I mean, you don't need to know that this is, you don't need a label here. I mean, it's pretty clear this is a name. You need a label here, of course, and then you need a title. So we're going to fix all of that. So the first fix I'm going to do is to kind of revert, or rather reverse this. So we're going to reverse this. This is a pretty popular Pandas trick, where if you want to reverse the data frame, some of you might have seen this. So what this is saying is that, like, I want all the rows and all the columns, but basically I want it reversed, right? So this is a Pandas trick. If you're not familiar with it, it's a very useful, very handy trick. So we fixed the first part. We have all the so we have all the bars lined up correctly here, and now let's kind of fix the remaining pieces. So let's add a title. So I'm going to say title is let's say most popular names of the decade in the US. Let's do that. Then let's do the y-axis titles. I want to remove the y-axis titles. So y-axis underscore title, I'm going to say none. We have another y-axis. As you can see, the Plotly treats the two y-axes separately. So we're going to do y-axis 2 title is also none. And finally, we want an x-axis title, which we will basically call it number of births, right? So that we are explicit. And at this point, I think the plot looks fine. It looks a little squished to me, so we want to increase the height. So let's increase the height. The way to increase the height is you just add a height parameter here. I'm going to basically say height is 500, and there we go. So that's our first question, first part of the first question. And as you can see, you now have like the top 5 names. You can do a lot of interesting things now with the same code. So for example, change, like instead of this decade, you want to know like the decade in which you were born, what are the most popular names. You can basically play around with it and do quite a few things. So let's kind of head to the next part of the same question. And so here, what we're going to do is we want to plot the trend in the number of babies for a specific name, right? So like, let's take an example. Let's take the name Noah, right? We now know that after 2010, Noah is a pretty popular name, but we want to know like what's the trend in this name been. So let's figure out how to do that. And once again, I'm going to start this analysis by using my method chaining. So let's start with baby names, head. So everything is good. So what I want to do is first, this time around, I want to basically take a particular name and I only want to look at those names. So the way to do it, again, I'm going to use my query method and I'm going to say name equals. In this case, let's just use Noah, right? So this will filter only for Noahs. If I run it now, you see that I have only Noahs here. Let me also sort the values by year. So we can say sort values by equals year, and this will basically sort them in ascending order. So you can see that the names go all the way back to 1880. And if you, one of the things you notice, if you're not very familiar with Pandas, you see these numbers here. These are basically the indices of these rows. Pandas preserves them. In some cases, it's not really, I mean, it doesn't look that great. So in this case, we're just going to add a reset index method at the end, so that, I mean, it's all kind of, you'll see what happens. It goes back to like 0 and 1, and let's do drop equals true, so that because you see Pandas basically when you reset the index, it moved the index to the column, which we don't want. So let's do reset index drop equals true. So you see now that you have all this, right? So how do we plot? So now we need to plot this, right? So there are two ways of plotting using Plotly Express. I already showed you one. We could take this data set, store it, and then basically we can use Plotly Express. Another way to do it, which is kind of a really cool way to do it, is to use Pandas has this ability to set the backend for a plotting library. So for example, what we're going to do here is we're going to say pd.options.plotting.backend, and we're just going to say Plotly. So what this is telling Plotly is that, hey, telling Pandas is that please use Plotly as your plotting backend. Okay, the default is matplotlib, which is good, but you won't get interactive plots. So now with this, the advantage is that you can essentially chain the plot method directly. So I'm actually going to chain the plot method here. So I'm going to say plot.line, because that's the plot I want. I want a line plot. And it'll pass on the data frame automatically. And my X variable is going to be year. My Y variable is going to be births. And I want the plot to be colored by the sex. So I'm going to say color equals sex. So let's run this code now. Let's see if it works. Yeah, it does seem to work. You can see how it shows actually the name Noah actually is predominantly a male name. There are very few females with this name, and you can also see how it kind of picked up in popularity sometime in 1993, and then went all the way, and then it's kind of like stayed popular. So it's kind of one of those names that became very popular, like starting 1990s. So we're gonna basically now do a few more things here before we go to the next part. So the first thing, I still need to do a couple of things to sort of set things up. So I'm going to save it to Fig, and let's do Fig update layout. This is just to kind of make sure that we have like all the titles. It's never publish a plot without a title because you need context. So this is basically popularity trends trend in the name, and then basically Noah, right? And I'm going to x-axis title. We don't need to say that it's year, like it's understood. So let's take out the information. Y-axis title, let's just make it number of births, right? And yeah, we can do more, but I'm going to just leave it at this, right? So this is good, but let's say that you suddenly want to analyze like other names, right? Like you want to quickly look at, let's say, Elizabeth or Ava, or one of the names that you see here, Mason, right? You could do, I mean, the conventional way to do it is just to change it here in the code, and like everything is good. But Jupyter Lab and Jupyter basically provides a really powerful way to explore data in a very, very interactive way. And I'm going to show you how to do that. And it's one of the most powerful features of Jupyter Lab. So to do that, I'm going to turn this whole thing into a function that takes a name and basically does the plotting, right? So here's how I'm going to do it. I'm going to say def. This is, as those of you who have done Python for quite some time know, this is defining a function, and we're going to say plot trends. And it's going to take one argument, which is the name. And what I'm going to do now is I am going to indent this so that this becomes the body of the function, and I am going to return the fig. So the function needs to return the actual figure. And the few other fixes I need to do is I need to now reference the name, and the way to reference a parameter in a query is using @. So this is basically saying take the name and plug it in here. And for this one, I'm going to basically use an f string. I'm going to put the name in here, and I'm going to use an f string. And let's just make sure that everything is good before we go to the interactive part of this. Plot trends, and then I'm going to say Noah. So if I did everything correctly, there are no mistakes in the function, then you should be able to see this. And let me just full screen this so that you can see both the code and the plot, right? So I want to essentially now make this interactive, which means that I want to be able to select the name and like choose. Plot Jupyter Lab has a really powerful feature called it has a module called interact, and so we're going to basically load it first. So I'm going to say yeah, I'm going to basically say from IPython. Actually, I need to look this up. I've forgotten which module contains the interact method. So apologies for that. Let me just quickly go over to that part. Actually, never mind. I'm going to Google this. Let's just interact module IPython. Using interact. So let's just make sure. Okay, so it's from IPy widgets. Okay, so I'm going to copy this and let's go back to the notebook and let's stick it in here. We only need interact. We don't need anything else. So I'm going to basically get this off. So from IPy widgets, and I'm going to say interact. We're going to use it as a decorator. And let's say I only want all the popular names. So I'm going to say popular names dot name. So that's basically going to list all the names. And let's just run this. And there you go. So you now got a UI for free where we can essentially just toggle the name here, and you can now see all the popular names. You can look at all the trends in these names. So this is a really handy feature in Jupyter Lab. And just to recap it for those of you, because I had to kind of switch to a different screen, what you need to do is you need to import interact from IPy widgets, which is basically the module. And then this is a decorator in Python. And then what we're saying here is that, hey, for this function, please use the interactive method. And these are all the names that I want you to provide. And IPy widgets automatically figures out that we are providing a list of names. So it gives you a dropdown. Okay. So I'm going to comment this out for now so that we are only going to do plot trends Noah. And at this point, I'm kind of almost done with the first part of the first question. And at this point, let's kind of showcase like what we do, what Workspace is all about. So now if I want to share this analysis, I can basically go over here and I can select the notebook that I want to publish. In this case, it is going to be notebook. And I am going to say, yeah, I'm going to basically say, I'm seeing update here because I published a version before, but in your case, you will see just publish. And once the workspace is published, you will see this is going to stop circling around, and you will get a link. And that link is something that you can share with others so that they're able to see your analysis. So then if I click here, you will see that this basically has my analysis. It has all the code, the reading the data, exploring the data, the popular names, also the top 5 names, and also the name trends in the name Dua. And of course, the remaining parts we haven't yet filled out. But so at this point, I'm going to pause. Let's take questions, and I'm also going to give the ball back to Rio. He's going to start a poll because we're going to decide what's the next question we want to analyze, and this is the list. There'll be a poll, and Rio, over to you. Rio?
I think Rio is having technical difficulties at the moment, so we'll launch the poll right now to find out what the next topic is. So launching that now.
Yep. Thanks, Ryan.
Okay, I'm back, Ramnath. So then, yeah, the first option that we can go to is trendy names. So what are the most fashionable names, sort of, that had a very big spike in a short time? After that, we could have unisex names. So what are names that are very common for both sexes? Then we have length of names. How has the length of the names changed over the years? What are the most common first and last letters is also an option. And then estimate the age from name. So that would be quite a longer one, quite a longer question to solve. but it basically, the idea is that you estimate how old the person is based on his name. But it's also a very interesting one. So now you can vote, and without further ado, let's already answer some questions. We have a first question was from Dorj. Can you please explain briefly what it is the purpose of the capture magic function?
Awesome. So this is one of the functions that you'll really love. Let me actually do this without capture, and you will instantly get like why I'm using capture. So basically, Jupyter, any cell in Jupyter, when you execute, it's going to essentially print like the output of the particular function. Now, obviously, if I publish this, like the reader is going to have to see all this sort of mess right at the top. The capture magic, what it does is it basically tells Jupyter, hey, like this cell, yeah, execute it, but please don't show me the output. I'm not interested in it. So usually what I recommend is run it the first time without capture, because you want to see if everything is working. You want to see if your libraries are actually installed. But once it does, just add capture so that, yeah, you don't have to worry about seeing all that again. I hope that answers the question about capture.
I think so, yeah. And maybe let's go to another question. Please, could you re-explain what if we set as index to true?
Yes. So
the line I mentioned.
Yeah, so let's actually let me actually open another code chunk here so that it's easy to understand what happens if I set as index equals false. So usually as index, yeah, let me actually forgot this part. Let me get this indented correctly, and then oops. Well, we have the poll results, which we will just get to in just a bit. Hang on. So let's just do .sum here. I'll just get this full part out here. So you can see that when you do group by, what Pandas does, it basically promotes the columns as indices. So as index is actually true by default. But if I set as index equals false, basically we're telling Pandas like, hey, I don't want this as an index. And if you do that, now you see that, yeah, so you can see how if you set as index equals false, you get this. So it basically it makes the need for a reset index at the end like not necessary, but there are pros and cons. There are some advantages of like keeping the index, which goes beyond the scope of this code along, but you could definitely look it up. Do you want to do a couple more questions, Rio, and then we will need to go to the question, the second question. So
yeah, if anyone has any other question that they would like to answer, now is the time, else we will move on.
How about you get your questions in the chat, and we have another Q&A at the end. We'll deal with that at that point. Let me just delete this this code chunk. So yeah, so we kind of predicted that this is the question that a lot of people would be interested in. So if you're in the notebook, you can actually use the this is the table of contents link that is shown up on the left sidebar. It's a quick way to kind of get to the question that you want to go to. So we're going to go to estimate age. This is actually one of the more complex questions, as one would kind of expect. So this is going to be a pretty loaded sort of 20 minutes. So follow along, have questions, raise them, and I will do my best to make sure that like everyone understands what we're doing here. Okay, so without further ado, let's get to estimating age. So first of all, like how can we even estimate age based on a name, right? And here is basically the trick. So the trick is we already know how many people with a given name were born in a particular year. On top of it, if we can overlay how many people with that name will be alive in the year 2020, then we have a distribution of births of people who are alive. And based on that, we can use the distribution to infer different elements of, I mean, the age of the person. So to do this, there is a very useful data set that's usually provided by, again, by Social Security. It's called life tables. And what it contains is that it basically says, like, for every year, people born in, let's look at one of these numbers, and I'm only going to focus on the column LX because that's the only thing that's relevant for this discussion. So what this number is saying is that out of 100,000 people born in the year 1910, right, around 78,275 will survive at least up till the age 39. So that's basically the interpretation. So in other words, this is giving us an indication of like what's the probability that a person born in 1910 will be alive in the year, in this case, of course, 39 years. So it's going to be like 1949, right? So that's the data we're going to use. So let's get started. So first thing, this data actually was in HTML. We scraped it for you and downloaded it. And basically, we put this into the template. So one of the things, if you notice, like you're doing all this to the template, one of the powerful features of Workspace is that templates can wrap things around for you. So you don't have to kind of do that repeatedly. So let's read the live tables using Pandas, and we're going to use the read underscore CSV method. And let's say live tables, and this is just a CSV file, and we're going to say live tables. So let's just get this, and let's print the first 5 rows. Live tables.head, and yeah, as you can see, you have all these columns. We only need like age, sex, year, and LX. So I'm just to kind of keep things clean, I am just going to select those here. So I'm going to say year, age, sex, and LX. And there we go. So we're going to print only these 4 columns. So let us now figure out like how to, first of all, it's good to visualize this table. So remember, we are only interested in people alive in 2020 because 2020 is the last year in the data set. So 2021 data is not there. So the question you're trying to answer is like, what percentage of people born in the year X will be still alive in 2020? So effectively what we're saying is that I want to look at all the rows here where the year plus age equals 2020. Okay, and like then we can see like how the plot looks like. So let me again do my have the parentheses opened up here so I can do the method chaining. So we're going to start with live tables, and this is usually my sanity check to make sure that my indents are correct. Everything is fine, so it's good. So let us start by querying, and in this case we want to do query year plus age is 2020. So that basically says I want to know like how many people born in 1900 will live up to the age 120. I mean, which is kind of pretty unlikely, but hey, this is we want to consider all possibilities. Okay, and so now let's kind of try to visualize this, and we are going to use the let me also sort first. Sort values by equals year, and I'm going to use the plot line method here. X is year, Y is age, sorry, Y is LX, right? And color is sex. Okay, so let's just do it here. And you can see here like how this looks like, and it kind of makes sense. Basically, you can see like if you're born in 1920, there is very few people born that year who are alive, and then of course it keeps increasing as you go along. So this is good, and let's actually in this case I want to save the data for the whatever I've queried. So like although I've kind of put this into one single function, I'm going to basically do it slightly differently. Live tables 2020 because I want the data stored. So and I'm going to move this to the same line because the single line, and then I'm going to basically then plot with the with live tables 2020. So just a little bit of reorganization of the code, but pretty much should give you the same thing. And let me add the title right here. Title is survival curve for just 2020. Like we'll make it more descriptive, but for now, let's just keep it here. There are a couple of challenges before we can do the estimations. The first challenge is that this data, if you actually notice, it doesn't come across in the plot very cleanly. But what you'll know, if you look at the data, you'll notice that it's there for only every 10 years. So and what the plot is doing, it's interpolating it, but we need that number. So we need to know, like, we need to know how many people born in 1921, 1922 are alive in 2020, and that data is not there because the life tables basically is every decade. So to do this, we need to interpolate. So we need to take the people alive in 1920, 1930, and then essentially like fill in the gaps, right? This is another really good exercise for pandas. And so what we're going to do now is we're going to smooth the life table by imputing missing values. So this can get a little complex, but I'll try to kind of keep it. I'll try to explain all the details. Your questions, please feel free to raise them in the chat. So let's take life table 2020, and this is my sanity check again to make sure that we have everything fine. Well, as you can see, like life table 2020 is not defined because I call it life tables 2020. That's actually bad naming. So I'm going to just call it life table 2020 and then go back here, and this should work. Okay, cool. So the way we're going to do the interpolation is, let me kind of go through the mechanics here, and I'll explain as I go through the mechanics. So the first thing we're going to do is we're going to set an index, right? We're going to set an index, and in this case, the index is year and sex. And if we do this, you can see that year and sex now become indices, age and LX kind of move out. I'm going to remove age for now. So actually, let's age is kind of redundant here. So I'm just going to go back here and remove age so that it's cleaner. So let's just do this here, and then I have here life. I'll bring back age later. I can't do that here. Sorry about the mix up here because I cannot remove it before this. Okay, so we're gonna keep things as is. I'm gonna drop it here. So here I'm gonna say drop columns equals age. Okay, so let's just do that here, and there you go. So you have year, sex, and LX. So we're gonna set the index, and now what we want to do is we want to include all missing combinations of year and sex. As you can see, we have 1910, 1920, 1930. We don't have anything in between, right? So to do that, we're going to use a really powerful pandas feature called reindex. And so we are reindexing the data frame, but in this case, we're reindexing it with all combinations. And how do we add all combinations? Again, pandas to the rescue. Pandas has a multi-index function, and basically what that does is you can say, okay, multi-index from product. I'll explain what this means. So this basically says that, hey, I want you to re-index this data frame, but I want you to use all combinations of this. So in this case, like first one is I want all dates from 1990, 1910 to 2020. So this basically will give you all the years, and I want male and female. And what the multi-index from product is saying is that, like, I want all these combinations, right? So the product here is the Cartesian product. And I also want to give them names so that, I mean, it doesn't make sense without names. It's going to be year and sex. And if you do it now, you will notice how, like, it added all these things, 1911, 1912. And if you print more rows, you will see that it actually added those missing things. So this is a really powerful feature of pandas, which is why indices are like amazing. So if you haven't explored indices in detail, I would strongly recommend doing that. We're still not done. We still need to fill in these values. How do we fill in these values? Well, let's group by, and I want to group by sex because we want to interpolate. One thing you might have noticed from the plot is that the male and female survival curves are different. So we want to kind of not interpolate for both groups together. So we're going to group by sex, and we're going to use the apply method. And what the apply method does, it applies whatever we're doing to each group separately. And so this is going to be x. We are just going to x.interpolate. Yeah. So you can see now how it kind of filled out, like the whatever was showing up as nans, it filled it out. So this is basically the smoothed table. So I'm going to save that here, life table 2020 S. So let's print it out here, live table 2020s. And the final thing I want to do is I want to reset the index. We don't need the index anymore because we want a flat table. So let's just reset index, and there we go. So now we have it filled. We have the values for male and female, and so it's all good. So we're almost there. We just have to do 2 more things before we get to the age estimation part. So let's do that. So now the thing we want to do is we want to essentially compute the number of people alive for a given name and sex, right? And basically this is what is going to give us that piece of information. So I'm going to write a function, but usually the way I like to write a function is by starting out by writing for a specific case and then moving the parameters up. So we're going to do exactly that. And before we do that, one last thing. Actually, no, you know what? Yeah, let's just do that in this part of the code. So let's start with our baby names back. And so we're going to take the first 5 rows. Let's pick a name. So yeah, I'm just going to pick a name here. So I'm going to basically say name equals. Let's actually do yeah. Let's just do Gertrude. And let me sort by sort value so that we can basically see yeah, by year, right? So we have this. So now what we want to know is we want to know how many people, how many Gertrudes of this name born in the year 1880, like, are alive in the year 1920. We don't have data for 1880, so this data will drop off. But so let's start adjusting with the year 1910. That's when we have the earliest data. So 1880 will not really surface, and unrealistic to expect somebody born in 1880 to be alive today. So what we're going to do now is we're going to use the merge method, and we're going to merge the live table 2020 smoothed. Okay, and I think it's on, and then we're going to merge. We're going to do year and sex because that's basically what you want. What you want to kind of merge it on. Okay, cool. So you can see that now the year started 1910, right? Because yeah, that's the earliest data available in the live table. What we want to do now is compute the number of people alive, the number of people dead, and we are almost there predicting age. How do we do that? Well, basically what we can do here is we can assign. So we want to add a new column that has the number of people alive, number of people dead, and that's what we're going to do here. So n alive equals, and we're going to use a lambda. And what the lambda does is basically gives you the data frame and allows you to use the columns of the data frame. So in this case, it's going to be lx divided by 100,000 because that's basically the probability that somebody is going to be alive. And this, let's put this into a parentheses, and then this is going to be multiplied by births. So that is going to be the number of people alive with that given name. This is taking a little longer, so maybe I made some mistake. Let's wait for the function to finish up. Okay, I think I know what I did. I should have referred to the column. So I'm going to I'm going to interrupt the kernel here. Okay, let's just wait. Okay, it's not interrupting. So basically, the mistake I made is I should have referred to the column in the data frame. So it should be d.lx and d.births, but I didn't do that. So yeah, this kind of is spinning around. I am just going to do a quick reset, just to make sure that I can get this working. So I'm going to basically, let's see, if I do a shutdown kernel, that doesn't work. Okay, I'm going to do an interrupt again or a restart. Okay, I'm going to restart the kernel. If you haven't run this code, please don't run it, so that you don't have to worry about this. So I'm going to go back and just run. I don't need to run all parts, so I'm going to quickly just get back up. Okay, let's see. Did restart the kernel? Okay, I think we're all back. So just give me 1 minute. I'm just going to make sure that I run the baby. I just need the baby names read, and that's pretty much what I need. So I'm just going to execute these code cells. I also need my plot trends function so that we're all good there. It's just rerunning the code cells. Okay, very good. So let's get back to estimation age. Sorry about the technical glitch here from my end on the code. So let's get the live tables here, live tables query, and live tables smoothed, and then back here. So what I'm going to do here is just to make sure that, yeah, let's just comment this out. I'm going to basically run this to make sure that we have everything. Okay, it's good. I'm going to move the head part up here, so we are not running it on all the data. We're only running it on the first 5 rows. And yeah, and let me correct this here. So d.lx times d.births. So let's see if that fixes things for us. Just double checking before I do this. Okay, so that was the bug I introduced, but yeah, now it's kind of solved. I can remove the head part now. So this is the number of people alive, and now the number of people dead is going to be nothing but lambda d, and this is going to be d.births minus d.n alive, right? So let's just get this part. So now we have number of people alive, number of people dead. So the final thing we can do, and this is why the age distribution becomes critical, let's re-add the age variable, right? So the way I'm going to do it here is I'm going to say lambda d, and this 2020 minus d dot year. So that's going to add the age back, and let me just plot it. I'm going to do a bar plot this time. X variable is going to be age. Oops. Y variable is going to be the number of people alive and number of people dead, because I want to plot both. And I am going to, yeah, and I'm also going to, just because I'm also going to add a filter here where the sex is female, given that this is a predominantly female name. And I think that should be good. Age, Y, yeah. So you can see from here like that, yeah. If this name was was popular early on, but like, yeah, like if your name is Gertrude, pretty much like you can see that, yeah, there is a lot of, it's a pretty old name. So you can see that, yeah, these are the number of people like who live up to this age, and you can see that they're all sort of here, right? So this is kind of the distribution of the number of people alive. So the way to kind of now, the final step for us is like, look at the distribution of number of people alive, right? And you can see that if your name is Gertrude and you're alive, then yeah, your median age is going to be like, yeah, somewhere around here, right? So that's why we're able to use this to estimate age. Okay, so let's kind of yeah, we can plot the age distribution, which is what we did. So I'm going to skip this cell. This is what we did before. One thing I want to do before we go there is like, yeah, I kind of make this premature mistake where I didn't save the data. So I'm going to call this, yeah, I'm going to turn this into a function basically, right? Because you want to do it for any given name and so let's kind of call this, define a function, which is age, alive, dead. And what we want is we want the name and sex, and basically this is going to become, and this is what we want to return, right? We want to return the data. And so if I now do, and let's kind of fix this as well. Let's do at name, and let's do at sex. Yeah, and I think we're good. I didn't give a title, but it's not a plot, so we're okay. And let's just run it to make sure that we are all good here. Gertrude, and then female. Yeah. So this is good, and now we can basically do the do that part here. Age, alive, dead, and we can do Anna, different name, and then or we can do a Michael. Let's do a Michael here. Male. Yeah. So you need. So one of the things, if you want to write multi-line chain methods, you need to use the parentheses in Python. So yeah. So now you can see if it's Michael, then this is basically distribution. So we've done all the hard work. We have the distribution. The question is, how do we go from the distribution to the age, right? So let's kind of just look at the data we have again. So age, alive. Let's try to estimate the age of a person named Michael, right? Age, alive, dead, and let's say Michael, and then male. So what we have is the two columns of interest are age and number of people alive. Those are the two columns that we should be interested in. And basically, we want to derive the quantiles. We want to derive the 25th percentile, 50th percentile, 70th percentile. This is weighted data. So typically when you have data, if it's raw data, you will basically have the different people at different ages. But here we actually have a weight. So for that, we already imported a module called W Quantiles, which is like a weighted quantile. So basically the way the weighted quantile works, and I will just show it to you for one name, and we can then turn it into a function. So I'm going to store this as the data frame D. And basically the syntax is quantile and d.age, d.nalive. So those are the weights. And then your quantile is, let's say, 0.5, 25th percentile. So what this is saying is that if your name is Michael, then the 50th percentile, the median age of a Michael in the US is 31. What we want to do is to get like all the 25th, 50th, and 75th percentiles. So basically now we need to turn this into a loop. So we're going to do a function here. Let's just say def estimate age, and we want the name and sex to be the parameters. And let's get this here, and let's and let's just basically I'll leave Michael and male for now, just so that we can run things. And then basically the quantiles we want are 25, 50, and 75. And I want to return a dictionary that has the name as well as sex, because you can basically turn the whole thing into a data frame. So what I'm going to do is I'm just going to define a variable called out, and I'm going to create a dictionary. Name equals name, sex equals sex. And now what I'm going to do is I'm going to compute the quantiles. The way to compute the quantiles, we're going to use a list comprehension. So for those of you, a dictionary comprehension. So it is going to loop through all the quantiles. So we're going to say for quantile, sorry, let me go back here. This for quantile in quantiles, right? So that's basically, and I'm going to change this to 25, 50, 75. I'll explain to you why I did that. Okay, and I'm going to call this Q. And here we're going to refer it as Q divided by 100. Okay, and what I want to do is I want to add a key, which is basically a Q plus a string of Q. So what this is saying is that when Q is 25, it's going to basically say Q25, quantile 25, right? And finally, I am going to update this dictionary to include this, and we're going to return the output. Hopefully, I've done all the steps correctly. We will get to know. So let's do estimate age. And yeah, one last bit I didn't do here is name and sex. Name and sex. And let's basically, I'm not going to use any defaults. So let's do Michael and male. There you go. So this is what I was trying to do here. I have the name, sex, 25th percentile, 50th percentile, and 70th percentile. So now how do we kind of turn this to, so we can use this now to get the age of any any person. So let's kind of do it for the most popular names. I'm going to rush up a little here. You can see the solutions for more details, just so that we have enough time for Q&A. Apologies for that in advance. So let's get the top 25 most popular names. Again, we're going back to baby names. And we're going to say, we're going to group by sex and name. And so I'm going to show you a slightly different way to get the top 25 names. So we're going to basically do this. So this will, I'm only taking births because that's what we need. And then I'm going to basically say sum here. So you can see now I have like all the sums, and this is a series in Pandas. It's not a data frame. But the advantage of a series is that I can now group by sex, and I can say n largest, and I want the 25 largest names. And Pandas is pretty fast with this. And finally, I want to convert this into a data frame. So I said reset index. The one thing I need to do here, which is a little annoyance, but you see that sex is repeated here 2 times because both group bys add their own indices. I don't want it to add again. So group keys equals none, and then reset index name equals births. This should do the trick, I think. And yeah, so now we have the popular names. I'm going to call it popular names all time. And let's go to popular names all time. So now all we need to do is to get it for all these names. And here we will basically follow a really cool idea in again in Pandas, where we can iterate through all the names. So what we're going to do is we are going to basically do popular names all iter tuples. So what iter tuples does is basically gives you a tuple of all the names, so you can kind of loop through that, and then I'm going to basically say for dn popular names dot iter tuples. So for d will contain each row separately, and then what I want to do is I want to estimate the age for each name and sex. So this is just a compact way of doing like doing the whole calculation. So I'm going to call this age name. If I did, and I'm going to turn this into a data frame, so you can see why I returned it as a dictionary. So we need a data frame. If I did everything correct, I should have popular names all. Okay, I called it popular names all time. And this might take a little while to run because I'm estimating the age. It's estimating the quantiles for each age. Again, my bad. I don't want to run this again, so I'm going to start a new cell so that we can just print the output. Age name. There you go. So we now have the ages of all the top 25 popular names. You can see the 50th percentile, 25th percentile, and the 70th percentile. And so so now you can apply this to like a whole bunch of things. And I'm going to skip the last cell, which involves the plotting. You've already seen enough of plotting in this code along. So so let's use the remaining time for Q&A, and based on the Q&A, I can go through more details. So Rio, over to you for surfacing the questions that people raised.
Yeah, great. So thank you very much for the great presentation. We promised we would be limiting it to 1 hour, but unfortunately the time has passed, since also we chose the big question of the 5. Now we're going to go over to Q&A. There are some interesting questions that came up, many more than last time even. Bharat and Aradita, they both asked, could you please put some more light on the interpolate function?
Yes. So let me go back to where I have the interpolate. Hang on, where's the interpolate function? Yeah. So basically, what the interpolate function does is it basically takes a series. So in this case, a series, as we saw, it had data for 1910, 1920, 1930, right? And it basically uses an algorithm to kind of like impute the values. And I think the imputation basically, one way to kind of look at what the imputation was, I think it's basically a simple linear interpolation, but we can check it out. Let's do live table 2020s. I hope that's still it's still alive here. Yeah, okay. So you can basically do, let's say, plot. Let me just get this going here. Oops. Dot line. Sorry. Plot dot line x equals year and y equals lx and color equals sex. And so you can see that it actually did a linear interpolation because between 1920 and 1930, you see that it's a line. I think the interpolate method allows other ways to interpolate, and so like if you really want to, I don't know more details about the interpolate function, to be honest. But yeah, so the interpolate, I think it's pd.dataframe.interpolate. It's a method on the data frame method. So you can see it fills NaN values. Yeah, method is linear, and you can use other methods as well. I think yeah, default is linear, but you can also do like, yeah, you can see all the methods here. The nearest. I know bits and pieces of this, so I don't want to give you any more information. Like, yeah, but you can check it out. Spline, pchip, Akima. Yeah, you can different ways to interpolate the data. But linear did the trick for us here. I think it's I mean, if you don't know too much about the data, it's just good to go with linear most of the time.
Okay, then we have another small question. Could you re-explain the capture function? Because I think it might be useful also for future.
Yes.
Future reports.
So yeah, so capture again, capture is one of the most useful ones, I think. Again, just to show you what happens if you don't use capture. So Jupyter Lab typically prints everything out, all the output out. So in this case, for example, if I run it, I'm going to see all this. It's useful information when you're actually doing your analysis, but I don't want to publish this with, I mean, all these details, right? Like this is not information that the reader of this article needs to know about. So when you do a double percentage capture, this is called a cell magic in Jupyter. And when I do this, it still executes it, but it just doesn't show you the output, which is very handy because when I publish this now, my publication, as you can see before here, like, yeah, it did not really show all those details. So capture is really useful.
Great. Then another question from Joe. If Lx is related to the probability, why is it scaled by 10,000?
Excellent question. Let me get here. So this is basically what is there in the documentation. So if you look at the documentation for the live tables, Lx is actually defined as the number of people out of 100,000 who are alive. So Lx is not the probability. Small Lx is not the probability. It's expressed as like number of people alive out of 100,000. So we are deriving the probability by dividing by 100,000 because like it's basically how you scale. So that's why we are scaling it by 100,000 because it's not a probability in the first place.
Okay, great. Then another more on the workspace side type of question. Apart from publishing the result as a Datacamp link, is there another way to export the results for a non-technical audience you would like to share it with?
Great question. So first off, I think yeah, this link can be shared with anybody, as you already know. So this link can be shared, and right now, yes, the code is also kind of seen here, but the workspace team is working on future things where yeah, the publication will be to that extent. The other way you can do things, again, it'll kind of defeat the purpose of being in the cloud, but you could also download the notebook. But then the disadvantage is that you will have to have a local Jupyter installed, and that's going to be limiting. You can also export the notebook in other formats, but the publication probably is the best way to kind of share, given that there is kind of no effort required once you do the publication.
Okay. Another question related to the first question, actually. Can you explain why we used group by twice in the popular name analysis?
Great question. Let me get back to popular names. Okay. So the reason we use group by twice, the first time we use group by, we wanted to compute the number of babies with a given name and sex born like after 2010. So this aggregation we wanted to do across sex and name, but we wanted to pick the top 5 names only by sex. So we want to pick the top 5 names for males and females. And that's why the second group by was done, so that we pick the top 5 in each sex. So that's the reason why we did 2 group bys. For those of you coming from R, like using dplyr, like dplyr basically handles it in a different way, where it retains some of the grouping information. Pandas does not. So that's why we had to kind of add this second group by.
Okay, and then maybe one of the last questions. Asha asks, what level of Python skills is this? Intro, intermediate, or advanced? Would you say?
Yeah, so I would say that for the popular names, I think it's basically beginner to intermediate. Essentially, you need to have familiarity with group bys and aggregations. But once you have that, I think you should be in a position to do the analysis. The estimate age one, that's definitely more advanced Python skills, because you're kind of looking at indices and you're doing interpolation and all of that. So for that, I would say, like, I think it's kind of intermediate to advanced.
Okay, great. Also, some people are asking where they can find the solutions. So maybe we should show them in the library where they can access it.
Yeah. So if you already use the template, then you will see that there should be a file called notebook solution, notebook solutions.ipynb. And that basically will contain the solutions. And if you can't find it there, we will figure out a way to get you the solutions, get you the solutions notebook. And also, like, I'll also publish the solutions notebook, so you can have it.
Okay, great. I think our time is up also for the Q&A. There should be a survey link in the chat. It really helps us a lot to get better feedback, and these events, they get better with your feedback, so it really helps. To round it off, we would like to thank Ramnath very much for the presentation, and you, the attendees, as well, for your participation throughout the session. We will be organizing more of these in the future. So go ahead, Ramnath.
No, go ahead. Sorry.
So yeah, stay tuned to further news on social media platforms, on Slack, and on the webinars page itself, and let us know if you have any additional feedback. This rounds off the first Workspace live code along. So I'll let you have the final words, Ramnath. But from my end, I wish you a very good rest of day or evening, and I hope to see you in the next one. Thank you.
Thank you so much, everybody. It got pretty intense towards the end because of the question that was picked. But I hope you learned a lot, or at the very least, you got more interested in discovering using data science to discover patterns. So if you're interested, we've also kind of provided a template for French baby names. So if you don't want to analyze the same data set, you want to apply the things we did for this data set, you want to apply it on the French baby names data set, there will be a link to the French baby names data set. We made it available as a template, which basically means once you click on it, you will have the data set and a starter notebook in place. So feel free to use that, and and if you publish things, let us know. Hopefully you all had fun, learn things, and thank you so much for the time.
Yeah, thanks everyone. Reminder that the link will be posted on the social media platforms, as well as the French baby names data set itself, and also the solution to this, the notebook that we solved during this session. So thank you very much, everybody.